I got stumped by one of my first year apprentices here recently. So we were talking about voltage drop in class, and I had a student ask, why is the number 2 in the numerator of the single phase voltage drop formula? I went on to explain that it's because we have to account for the resistance of both circuit conductors. He then asked if we wanted to calculate the voltage drop in a multi-wire branch circuit, would we use the number 3 in the numerator instead of the number 2? Obviously, I knew the answer was no, but I didn't know how to explain it. I actually went home and thought about it for a while. In a perfectly balanced multi-wire branch circuit, you could just use the regular voltage drop formula because there's not going to be any voltage drop on the neutral. But what about in an unbalanced multi-wire branch circuit? I got to thinking about it and I realized that in an unbalanced multi-wire branch circuit, the voltage drop across each conductor is going to be different depending on the load. If you think about it, this is just Kirchhoff's voltage law, but with more than one path. My thought process was that if we knew the current across each conductor and the resistance of each conductor, that we can use amps times resistance to find the voltage drop from point A to point B on each conductor. To confirm my suspicion, I reached out to my friend Dustin Stelzer from Electrician U, and he sent me this video as a response. Cue the footage.
So yeah, I think that you're on the right track with all of this. There isn't a formula like 2 KID or, the square root of 3 KID over circular mils, because that's assuming both conductors have equal current on them. So for an unbalanced multi-wire branch circuit, you kind of have to just use Ohm's law, but you have to do it per conductor. So you got to kick the loads out of the equation. So when we're doing something like this, we're asking a different question than when we're doing something with, parallel and series circuits with Ohm's law. With this, we're only looking at the conductor. If we have a long conductor, what is the voltage drop going to be? And that's why we get a small number like 3 volts or something like that. But when we're using KVL and we're in a series and parallel circuit, we're saying with the conductor and the load combined, how much voltage is going to leave due to that load. So I think in our situation here with this imbalance, we just have to kick the loads out and figure out what each conductor resistance is. And you already know the current that's going to be flowing through, so you don't really need the load. But I've got everything figured out here based on like aluminum number 12 from the NEC, and I did 100 feet. So I'm getting, realistic voltage drop values.
So I drew up this scenario right here. Like Dustin said, the voltage drop on each conductor is going to be different depending on the load. Now, to make this math real easy, let's say that these circuit conductors are exactly 518 feet of number 12 copper, which means that each conductor is going to have a resistance of exactly 1 ohm. We know that using Ohm's law, voltage equals amps times resistance. So if we have 1 ohm of resistance across each circuit conductor, then we can use Ohm's law to calculate that. So 15 amps times 1 ohm equals 15 volts dropped across L1. Same with L2, 10 amps times 1 ohm equals 10 volts dropped across L2. And then 5 amps times 1 ohm equals 5 volts dropped across the neutral.